All right, welcome to another one-on-one math lesson. In this lesson, so Mr. An and me, Mr. An and I, we will deal with interpolation and extrapolation in using graph and tables. All right, so you have done some at home yourself. So let's continue, Mr. An. Right. So basically, you just have to guess the values based on is it in or out of the range. Now, so what do they expect? Look at the main graph again. Estimate power's time for a 120-meter race. So what can you do? Tell me.
So
Yeah.
for a 10-meter race, it's like somewhere just like this pattern's like it's linear, but
Yeah, but for zero, yeah. Well, okay, zero is a special case anyway.
yeah,
But
super
anyway,
special case.
um, they ask you to find power time for a 120-meter race. So based on that graph, you can see that it touches 120, and you can go to horizontally. You can go horizontally, you will get to the number of about, say, 11.5, right?
Yeah, 11.5, approximately
Something like
that
that.
number.
Yeah, that should be the answer we're looking for. Just putting honey into my drink now. Tastes a bit better now. Okay, just write it down. So using a graph, I can estimate or extrapolate that for a 120-meter race. The time is approximately 11.5, yeah,
10.5 seconds.
second. Okay, good. Now let's show suggested answer. Yeah, something like that. Now, so beside from tables, graph, we can also extrapolate using an equation. So the third way. Do you feel more confident now with math?
Yeah,
It's the general feeling that matters, I mean, for people like us, it's the general feel that matters. Okay, let's go down and you have extrapolate using equation.
we can write an equation to represent this relation. We know that the first difference is 0.85 for distance, increments of 10 meter. The rate change will be 0.085 meters per
Per
second,
second.
and we can approximate from the graph that the initial value is 1.25.
Okay, let's go back to the graph and see if what they said is correct. So 1.25, huh? Oh, so that's when it touches the zero meter distance, and it touches the y-axis. It touches the y-axis at about 1.25.
Yes, close to that.
So that's the initial value, yes. And so rate of change. So 0.85, the furthest one for distant increment of 10 meter. So okay, so the rate of change will be it's like divide by 10. So you get 0.085 meter per second.
Mm. If you need to extrapolate the time for 110 meter, substitute 110 for x. So then y equal
And then
0.85 and remove the x and put it in 110. You
and then you
take
have
0.
mhm,
You take the 0.85 and then multiply by
times
110, which you get 9.35. And then plus 1.5 and you get 10.6 second.
all right. So,
So
but this one extrapolate using an equation. You have to find the equation first, and then you put the values into the equation. So it requires one extra step. I mean, all the ways. I mean, doesn't matter what way, but it must arrive at the right answer. So
the prediction is 10.6 second, which is the same answer we got from the table, and closer to the answer from the graph. Calculate the time for 120 meters second. Distance. So it will be 0.85 and then x plus 1.25 base. And then you substitute the x for 120. 5
times 120. Yeah.
20.
I think it's better if you write the multiplication symbol, asterisk something. Oh yeah, you can do that. But now if you write x like that, it confuses with the variable x. So just write an asterisk. Asterisk. Okay, brackets and then asterisk if you want to.
Yeah, whatever.
Oh, whatever.
Whatever.
Spacing. Just to make it look more nice.
Multiply by 120 is 10.2, and then plus 25 is equal to
11:45. Yeah.
11:45. Yeah, so the distance for 120 meters second is about 11.45 seconds.
Alright, so it's the same. It arrived at the same answer. And then they say don't forget the independent variable. So basically, if you want to find y, I mean, you can also use equation to find x too. That is the independent variable, right? I mean, you can use it to predict like the auto value as well. So it's both ways, So that's what they want to say. Like instead of finding y, now you are given the y and you have to find the x. That's what they want to say.
So then
Yeah, so
y
find x.
0.085x, and then you substitute y for 11, and then you bring the 1.25 over and subtract it. It's equal to 9.75 equals 0, and then you bring the 0.085 under, and you take 9.75, you divide by 0.085, you get like 114.705, which is equal to x then. So you round off, and then it would be 11 115 equal x. So you would predict that PO would be at the 150-meter mark after 11 seconds. Now can you
After 50
predict
seconds.
where he should be after 50 seconds?
Okay, you do that.
Yeah.
Be careful to check everything again, like check everything twice. You have this
Okay.
50 seconds.
So y equals to 85 plus 1.25. You substitute y for 50 equal 0.85. Bring the 1.25 over and minus it. Which now equal to so 50 minus 1.25 is
Okay.
48.75.
Divided by 0.085. You should get to about
85 code x. So it would be 48.75 divided by it'll be about
how much you have?
so
No, that's not right. That's not correct.
no, I'm still typing.
Okay.
3.52.
Okay, let's round it up to 5 then. 573.5. Let's just round it up to one significant figure, one decimal number.
So
Yeah.
yeah.
What? No. I mean, okay, if you want it that way, how many sig fig do they give you? 3 sig fig, right?
Yeah.
So 5073, I think, meter. Yeah. Towards 573.
And the just answer is
They gave all the way to 5 sig fig. Wow. They used like all 5 sig fig. Wow.
so he would be like at close to about 573 50 meters after 50 seconds.
Okay. Yeah. I mean, this is just like estimation because nobody run at the same speed. You know, it's like you go up, down, it's like that.
So it's like in a race, you would like slow
You have
down.
to try your best in a race, of course. I mean, but consistent
Because
speed,
when
I
you
don't
go
think so.
too fast, it's like too dangerous and
Yeah, and it's not
slow
like
down.
considering like whether you have to turn left or turn right in the intersection or something like that could be dangerous.
Yeah.
So
Yeah.
at crossroad or at intersection or wherever you have to turn, you have to slow down at that point. So of course, every other factors affect their speed and their distance as well, and the time they have to finish the race too. So this is just like theory. In practice, it's all different.
Yeah.
Now, but anyway, try it. The graph show how the volume rocks depend on its mass.
Volume centimeter degrees. Use the graph to predict the volume of a rock whose mass is 65 grams.
Yeah, sure.
So 65 is so I would say this is about
10.
10
Yeah, 10
centimeters.
sounds more like it compared to 10.3. Yeah.
Yeah.
Correct. Okay. The danger of extrapolation. Of course, there are dangers because this is just like prediction.
Yeah.
Okay, let's read it.
When you predict the value of variable within the range of the data point, it's called interpolation. You can usually be pretty confident that the
Prediction you get,
prediction you get is very accurate.
but
But in the last section, you predict that power will run 574 meters
after 50 seconds,
after
1.5 kilometer. Okay, that's what we think according to the theory. Do you think that's reasonable? You see,
I'm not sure.
I told you already. There are so many factors that involve in real life. Okay, let's just read it to give you a better idea. Yeah.
More than half a kilometer. Do you think that's reasonable? To give you a better idea of the world record for the 400-meter race is about 44 seconds, which means that power would have to match that pace and then run another 174 meters in 6 seconds. You probably realize that no one can maintain the pace required to run a 100-meter race for very long. Even a world class elite like
Aside
us.
from power, we get tired and slow down. Of course, he's human anyway. Like when you run like something like very fast, you basically exhaust your ATP. You know what ATP is? I mean, your energy
No.
source. Let's just say energy source. Your store energy source very quickly because basically when you run fast, you have to use extra energy to speed up. And
Yeah.
it drains out your energy quickly
It's like you have a
compared
limit.
to if you run like a long way, then you don't have to run that fast. But now when you run fast, it drains out your energy source very quickly. So even power, he wouldn't have matched that pace and run another 164 meter in 6 seconds. Oh dear.
The relation will no
No
longer be
longer linear.
linear. It's important for you to realize that any relation you discover will only be reliable for value of the variable that are between the data point that
That
you
have
have
been
been
gathered.
gathered.
Mhm.
The
Which
relation may
means
be
which means
true.
if you interpolate, which is between the values that you are given, interpolate, then the value will probably be correct. But if you extrapolate, it's out of the range, and there's a lot of things that can happen. So when you
Yeah.
extrapolate, it won't really be correct. It will not be correct.
The relation may be true outside of the data, but there's no guarantee.
No
This
guarantee.
has great importance in real life. You cannot make good decisions about important things unless you gather data that include a wide range of value for the variable. That's why Canada has a
Census.
census, which is a gathering of data from the whole population. Every 5 years, government and businesses must know a lot about us if they're going to make good decisions. Consolidation.
To self-assess your understanding. consolidation.
Consolidation. Try the following question to self-assess your understanding of this learning activity. Okay. Question 1. The speed of a car is given the following table. Predict how fast the car is going at 2.5 seconds. So in this view,
I have something to say. So basically, if you study with me throughout like many months later, I don't take a break. Basically, even during New Year Day, Lunar New Year Day, I still work because we are working online anyway. We don't have to go anywhere. So, I mean, even for my IELTS class, for my piano class, for my science classes, people still study during like holidays and all the other things all the day. Okay. So basically, this is just a head up for you to understand that we will keep on studying even though it's Christmas or New Year or whatever. You should let mom and dad know that too.
Yeah.
We are really serious with this, with study. I mean, I am.
So they're going about like the car is going about like 2.8 2.8
It's
2.8.
2.8 meter per second, isn't it?
Yeah. So since 2 point they're going about like 2.5 second, it's like a half.
Yeah.
Half of like so half of 2.8 is like 1.4, so 2.5 should be 2.5 of, so it's like it'd be like 7 second.
Yeah, 7 second. No, 7 meter. Sorry.
Oh yeah, 7 meter.
Yeah.
Or
2.5 seconds. Wait, the question asks how fast the car is going, not like how the distance the car has gone, you know. So basically, they ask for the velocity, how fast. So basically, it's still, I think, no. It should be 7 meter per second, actually.
No.
So once again, read the question very well. It's 7 meter per second. I should stand down. I should just sit down. Been standing up.
The dependent variable speed increased by the same amount of making the relationship linear. 2.5 seconds is halfway between 2 seconds and 3 seconds. So the corresponding speed must be halfway between 5.6 seconds and 8.4, which is 7 seconds, 7 meters per second. Question 2. Graphs show how the volume of rock depends on its mass. Use a graph to predict the volume of a rock whose mass is 55 kilograms.
You found it? 55 grams. Remember, 55 grams is basically out of the range now. And please, your microphone. Your microphone, please. Hello, I can't hear you.
No, sorry, I just
All right.
went to the wall.
Now, so basically, 55 seconds is out of the range, I mean, of the values you are giving, so extrapolation might be dangerous here. Isn't it? Oh no, it's
Yeah.
actually inside. It's actually inside of the values you're given. So now it's interpolation. So you can guess that it's about, say, 8.5, isn't it?
Yeah.
Okay, let's show suggested answer around that. You have to
Around
say the
that.
right units, okay? It's cubic centimeter.
Ram. Question 3. Suppose you're emailing and
And Kana, your American friend.
you want to tell her that it is 25 degrees Celsius outside. You will need to convert 25 degrees Celsius into a Fahrenheit temperature so that Kanchwana can understand it. The equation that relates to temperature in degrees Fahrenheit and degrees Celsius is F equal 1.8 C plus 32. If F represents the Fahrenheit temperature and C is the Celsius temperature, what's the temperature in Fahrenheit? So, so F would F equal 1.8 C plus 32.
This is a simple conversion.
5
Mhm.
1.8. It's
I think it's
40.
45 plus 32, 77, right?
F equal
Unit,
3
unit, be
plus
careful. Unit.
77
77 what?
degrees Celsius.
No, it's degree Fahrenheit because you're looking for a degree Fahrenheit now. Be careful. Units is important.
Degree for
Fahrenheit. And it should be in capital letter because it's a name of a person. Fahrenheit. Just another German, Austrian name thing.
yeah. And Hannah writes back and tell you that where she lived, the temperature is 95 degree Fahrenheit. What's the temperature in degrees Celsius?
Okay, so this is the opposite direction.
So then F is equal to 95. 95 equal 1.8 C plus 32. In the 32 over, so you get 95 minus 32. equal to 1.8. Let's see. So 95 minus 32 is
Today is like 20th, right? The 20th, isn't it? Oh yeah,
yeah.
Monday the 20th. I see. So this week, it seems like I have new classes.
Oh,
And Christmas, I have like 3 classes each,
that's
like
rough.
24th and 25th. Oh well, never mind. I don't mind because basically, it's nothing. There's nothing there anyway. I mean, we have
So
Omicron. We have Omicron and all the COVID going on around us. Anyway, this pandemic will radically change how humans react, how human traditions are um, celebrated, and all the things human.
yeah. So then 63 divided by 0.8 equals C. C is equal to 35 degree. So yeah, I got it right. Question 5. Nancy is exercising regularly. Her friend Lee count the number of push-ups she does every 10 seconds. According to his data, how many push-ups could Nancy do in 1 minute? 60 seconds. So I would say in theory it would be 42 push-ups. She would get tired naturally and would slow down.
84 push-up in 2 minutes. Do you think it's reasonable? Can you
No,
yourself do
it's
84
not.
push-up? Can you yourself do 84 push-up? It's impossible because after like about 12, 30 or maximum 40, you would feel extremely tired, right?
Yeah,
You
because
wouldn't be able to do that in like 2 minutes. Impossible.
unless you're like a superhuman.
Nah, unless you train really hard. But come on, I mean, 84 is just a lot. You know how hard push-up is? It's actually not that easy to
Really
do.
hard. It's really
It's
hard.
not
I
as
tried
easy.
it before.
It's not as easy as running, you know.
Yeah. This is not possible. Oops. She would get very tired over time. Yeah.
Impossible to maintain that initial pace. Unless it's a
Yeah.
robot, but come on, robots will heat up after sometimes. They will stop working too. I mean, because pushing up, you actually produce a lot of heat in your body.
Yeah.
Robots would probably be the same because it heats up after some time and it might slow down, or the machine may even get broken, you know.
Mouth.
It might melt. I mean,
Yeah.
maybe not melting, but it just malfunction maybe.
Yeah. Because every living thing has like a limit to its body. Yeah. You can't go beyond it, or else it would be like
Mhm.
it would be so painful. And that's it to the 4.4 using interpolation and extrapolation.
And then your share screen is off again.
Oh yeah, because I'm opening a new one.
Okay. So now extrapolation and interpolation is done, and so we come to the number 5. Is the topic number 5, isn't it?
Yeah,
What was it
4.5.
called then?
Okay. Right. Okay. Examine direction and partial variation. Let's get warm up by reviewing rates, equation, and graph.
Mm-hmm.
Suppose Carl is working out. He warms up for 15 minutes, then does circuit training, which take 10 minutes per circuit. A. What is the initial value for the relation in minutes? B. What is the rate of change for the relation? the initial value for relation is 15 minutes more power. What is the rate of change
Carl's
for the
working on
relation?
runs for 15 minutes and then circuit training.
And sir,
Circuit.
training. Training. And it's just close on me.
Oh, again. This place, I think this page interfere with zooms in a weird way. I don't understand.
I don't know, but I think it only happened for today.
No, it happens for many days already. It's no surprise that Vietnamese internet cables, it breaks like 10 times a year already. 10 times this year already. And it's because of course, ships. They drop their anchors down and then they just drag the cables and then finally it breaks. And when it breaks, the whole country got affected. It's terrible.
The So if you let T represent the time Carl spent and N represent the number of circuits he completes, what is the equation that describe the relation? So the I think this would be it happened again.
Of course it would happen again. Of course.
Yeah, let me just get it open.
Okay, there you go.
So if you let T represent the time Carl spent and N represent the number of circuits he's complete, what's the equation that describe the relation?
Sounds like the more time he spent, the more circuit he will make, right? So the time is a dependent variable. Independent variables, and this number of circuit is the dependent variable, right?
Yeah. So
So
I
what do you
think
think?
the equation would be t equal 10n plus 15.
Don't think so. I think it's n equal to 10t plus 50 actually. Because the more time you spend, the more circuits you will make, isn't it? So it has to be another way, like n equal to 10t plus 15. Think again. You will see that. Think again.
So it would be mm, I don't know. I'm just gonna go with this and see what the suggested answer looks like. So in case I got it wrong or I
Okay,
got it
just show
right.
suggested answer and you will see. Just show it. Wow! Congratulations! Not all the times I am right, you know.
Well, yeah,
Okay, let's see why. Let's see why now.
there's no why.
So 15,
Alright,
it's what? What is 15 then?
team is suppose Carl is working out. He warms up for 15
So
minutes.
that's the time he warms up. Aha.
Yeah, and
So
then the
10 minutes per circuit. So it's 10n plus 15 equal to the total amount of time he works out, right?
yeah,
Oh, then that makes sense then. I'm just toying with you a bit.
or maybe you didn't see the question, so you got
Maybe.
confused.
Maybe. But sometimes it's good to recheck and then, sometimes it's good to have some argument. I mean, not argument, it's discussion. So you have a better understanding of the thing you're doing.
Unless the discussion turned into an argument.
No, no, no. That's a discussion.
Sometime.
It
Alright.
requires education, respect, to have, fruitful discussion that will yield some kind of result. Otherwise, it would turn into like personal attack. Personal attack. Like, you know.
Yeah. The if you create a graph, what would the vertical intercept be in minutes? Um, if you create a graph, what would the vertical intercept be? Um, um, Wait, can I go to the washroom for a
Sure.
few minutes?
Sure then.
Intersects the y-axis, which in this case is when n equals 0.
Uh-huh.
T equal 10n plus 15. And so since there's like no time, so 10 multiplied by 0 is 0. And so it's t equal 15, which means he didn't do like the what's it, the circuit training, and
Mhm.
so it's only 15-minute warm up.
I think warming up,
He,
well, it's important, yes, but I think I would normally warm up for only 5 minutes. I mean, I don't have like a surplus amount of energy, so basically just do like quick warm up and then push up, lift up. Just don't exercise for too long. It doesn't help the muscle to grow that much.
Yeah.
Cardio and long, like 1 or 2 hours practice. It basically trains your endurance, but it doesn't train. It doesn't really help you grow muscles. That's the thing. And I want to grow muscles, so.
Okay. You pick the graph that represents Carl's training plan. So 15 and there's 10 minute for just 20. Third one. Yep. Action. So far, we can represent Carl's
Carl's training
training,
relation.
yeah, training relation with the equation t equal 10n plus 15.
And the
And the
graph
graph
is.
is as follow.
Hmm.
So it's like 15 somewhere here, and then one circuit is 50 minutes, so 15 plus 10 is 25, 25 is around here, 35, and so forth. Direct or partial? Look at Carl's training graph. Notice that the graph does not begin at the origin, 0, 0. Rather somewhere up the vertical axis. In previous lesson, we have seen relation whose graph passed through the origin. In mathematics, this turned out to be a big difference. The difference is so important that the two type graph are given special names. Relation where the value of the dependent variable is directly proportional to the
Proportional to
value
the
of
value of the
the
independent variable.
are called direct variation. Equations are the form of y equal mx, and the graph always pass through the origin.
Of course, because
0,
when
0.
x equal to 0, y equal to 0. So that always pass to the origin.
Relation where the value of dependent variable depends on both the value of the independent variable and some initial value are called partial variation. Equations are the form of y equal mx plus b. And the graph never passed through the origin. Is the relation between time and the number of circuits that called as a direct variation or partial variation.
What do you think?
Um, I think it's a direct variation.
No, it's a partial variation because it follows the y equal to mx plus b pattern, you know? Remember, it's t equal to something plus 15, isn't it?
Yeah, yeah, that's
So of course, it is a partial variation because it doesn't go through the origin at all. It doesn't.
oh,
So it's a
yeah,
partial
but
variation.
mm,
Check again, please. And you can say it. There you go. It doesn't pass through the origin, isn't it? It's
yeah,
always something like it starts with the number 15, you know, and going up. So this is not what's it called? It is a partial variation, not a direct variation.
yeah. So what if Carl changed his routine? Let's use a graphing tool to look at how the graph and equation would change if Carl changed the amount of warm-up he spent before doing his circuits. His initial workout would be graphed as shown using the equation y equal 10x plus 15. Can you predict what will happen to the graph if Carl changed the length of his warm-up or the time spent doing each circuit?
You didn't
What
slide.
did?
So you have to use a slider on that graph. Increase
Yeah,
hour time to 20 minutes and increase of 10. Uh huh.
Carl warm up to 20 minutes,
And
then
decrease it to
decrease it
10 minutes.
to 10 minutes.
Record the equation and the lines. Okay. What happened to the graph? Okay, let's try it. Just try it. You slide the slider, you can see.
Okay, let me share the
Oh,
screen.
again, share screen's off.
No, I'm trying to share this.
Okay, you're sharing now. Okay, good. Now, so try to increase the warm up time to 20, and you can see. Yeah, that one. Slide it to 20. The graph just going up, isn't it? Yeah, because it started at 15 and then it just going up to 20. You can go back to 15, you can see. Yeah, it's going down now. Okay, so when you go to 20, it's going up, isn't it? Try it. Just try to slide it on yourself on your own, and you can see. Yeah, it's going up. See, the graph is going up, and if you change the number of minutes per circuit, it actually causes the graph to change in its how can I say, angle, like the slope of the graph. Try to slide the one down there. Adjust the angle or the slope. You see? I like this kind of graphing method. I mean, this website explains things very well, actually.
Okay, go back. Question 104. When the value
Initial
increase,
values increase the graph.
the graph, the initial value is move up.
Correct. Initial values decrease, the graph moves down, of course.
The rate is increased, gets steeper, and get less
Decrease.
steeper,
Yeah, less steep.
less steep.
And a consolidation, let's try it.
So far in this unit, you learn or
Or
review
review,
how to
okay,
create
the
a
spoken
description
word.
in your of a linear relation that would represent a table of value, a graph, an equation, how to change between all four representation of a
Was
linear
represented as
linear relation, how changing the initial value or rate change in a linear relation would change the equation and the graph of
the relation.
the relation. Now try to review quiz to see how well you can apply these skills. Which of the following stories should be described the relations show on the graph? Joe weight 200 pounds and lose 5 pounds each month. Kara is riding in an elevator. The original height of the elevator is 300 meter and it's going at a rate of 5 meter per second. Abraham is tracking the value of the bank stock. The value of the stock was $300.
Initial
When
value
he
and
got it,
increasing rate.
its value is increasing at the rate of $5 a month.
So after a year, it's like increased by 60, huh? That sounds
Yeah.
good.
Sonia has $300 and spending $50 per month.
Remember, look at the graph, it's decreasing, isn't it? It's going down.
Yeah.
So it's gonna be something that will decrease through time. So 5, 10, 15, 20.
Wait. 5,
There should be no
25.
indication.
I think it's riding an elevator.
5 meter per second. You think so?
No, no.
There's nothing else on the graph to indicate what it is, isn't it? It just
Yeah.
10. Okay. 5
Well,
meter per second. Okay,
you
so where do you start with? Where do you start with? Is there anything else on the graph? Can you scroll up?
there's like number.
No, I mean, can you scroll up a little bit? Okay, there's nothing else. Okay, so seems to be nothing else. Huh? If it goes down at a rate of 5 meter per second,
No, I
no,
don't
I
think
don't think
so.
so. I don't think it's the elevator
Yeah,
thing.
because when it reached like 20, it's like 25 multiplied by 20, it's equal to like
100. I don't think it's the elevator case.
yeah.
Maybe it's the amount of pounds that is that has lost so far, that Joe has lost so far. Maybe. What do you
Yeah,
think?
yeah, I
5 pounds.
believe so. 5, so
Mhm.
5, 10, 15, 20, 25. No, no, I don't think that's
It's not. Spending $50 a month.
Sonia Han.
I don't think so, because 50 is nothing to do with this graph. The number 50, there's nothing to do with this graph, right?
Yeah, 50 is like way too much.
Yeah. It's not.
Abraham is tracking the value of the bank stock. The value of the stock was $300 when he bought it.
But the value increased, but this graph is decreasing.
Yeah.
So, no.
Aura is riding in an elevator. The original height of the elevator is 300 meters, and it's going down at a rate of 5 meters per second. It's either Joe who weighed 200 pounds and lose
It
5 pounds
sounds
every month.
more like Joe weights, I think. Because basically, the x-axis can represent the number of pounds he losses so far, you know.
Yeah.
Or it can either be like the distance that the elevator has traveled. I think could be both. Okay, let's just
Well,
try it and you'll see.
okay. Oh,
Oh, it's correct now.
it's car.
But but how about Joe thing? Let's see. This is £5
Um,
every month.
oh wait.
Could be. You are not allowed to choose again.
Yeah.
5 to 300.
Wait, let's think about Joe for a few seconds.
Mm-hmm.
So he's like weight 200 pounds.
That is
So
the B. Yeah, that is the B you start with. And loses £5 every month. So it's going to have that equation like y equal to £5 per month. So 5x
wait. So
is minus
5
5
months is
actually.
25. 10 months is 50. 15 months is 125. And then 20 is 150.
Okay, I'm going to
Wait,
write the two equation for you. So basically, original height 300, going down at a rate of 5 meters per second. So minus 5 times t times plus 300. So these are the two equations, okay.
yeah.
But why? It's weird.
I don't know. Maybe let's go to the next question.
Oh,
Which equation would match the following situation? It costs $200 to rent a hall for dinner and $20 per person for the meal.
This is not that hard. You can do it.
Yeah. So it would be, yeah, because the 20 is like the n is
A person.
representing the
Number of person.
person,
Mm-hmm.
and
200 is
it's like
like
the
the
rate,
cost of
the
rent a
rate.
hall, like a fixed rate of rent a hall.
Yeah,
Mm-hmm. Which type of
three.
values would represent the equation that? Okay.
Which table value of the we could represent by the equation y equal 5x minus 2.
First, you have to see if the value is going up or going down.
Let's see. I think it's A.
No, it's not. Because why? Y equal to 5x minus 2. So the graph should go up, right? Going up, going up. But you can see the values like 5, 3, 1, -1, -3. It's going down, isn't it? So it's not A. I'm sure it's not A.
Oh, yeah.
And if you put these values, just try it, put it into the equation. You can see that it doesn't match.
Yeah,
Just plug it
yeah.
in, you can see.
So,
So you are left with three cases left: B, C, and D.
so 5 times 1 minus 2. I think it's D. No, no,
Oh,
no.
are you so sure about that?
Yeah, because if 5 multiplied by 0,
Mm-hmm.
then it's 0, you minus 2
Okay, then try
become
another
negative.
value.
And then it's like 5 multiplied by 1, it's like 5, then you minus 3. You get 3.
Okay. I mean, all value will fit, right?
Yeah.
Okay, there is another way to see it quicker. You see, between the values, let's say -2, 3, 8, 13, and 18. The difference is 5, isn't it?
Yeah.
So that is exactly the equation, say 5x plus something. But look
Yeah.
at C, for example, 5, 7, 9, 11, and 13. It's like a difference of 2 each, right?
Like, yeah, so it's like
Which
adding
is not
2.
what the equation represent. For B, for example, 2, 7, 12, 17, and 22, actually a difference of 5. So now we have only B and D left. But then, once you try the first value of x equal to 0 in there, it doesn't result in -2 like the equation represent, right? Okay. Let's start with B now. Let's start with answer B.
Okay, so
And you plug the first value in, it doesn't it doesn't prove true. So basically the only answer is D.
yeah.
Okay, let's show suggested answer. Okay, let's continue.
Which graph matches the situation where a car is driving away from you at a rate of 25 meters per second and is originally at a position of 50 meters from you? 25 seconds. 50-meter away. 50-meter from you.
Sounds like okay. Can I see the autograph?
The other graph.
It sounds like you have only B and D left to choose, isn't it?
Yeah. Yeah. My answer is table 3.
Why?
Like it start from 50 and 1 second is like 25-meter
That's by
away from
25.
you.
Exactly like what they show, isn't it?
Yeah.
Okay. Good.
Yep. Table B.
You're getting better.
Erica has drawn a graph to illustrate the linear relation between the cost of attending movie and the number of movie a person attend at the best of oldies theater- theaters. Best of oldies charge membership free of $25. It then costs $15 for every movie she attends. Best of Oldie has decided to change its price structure. It's, it's planned to increase the membership fee to 40 and reduce the charge per movie is $12. What effect will this change
In
in
price
price?
structure, make it Erica's graph.
Okay, I think this. I think it will move the graph upward because it started at 40, so 25 is like lower than 40, so move up and then reducing the price make the line like going down like steep a bit.
Mhm.
So but
Try again.
oh yeah,
Less deep or.
less steep. I didn't read it carefully.
There you go. You have to be careful. Of course, you have to always be careful.
And that is it for 4.5, examining direct and partial variation.
Oh,
Yeah, that's the
again, please. Again, please. Share again, please. That's weird. Why now you share and it doesn't mute your microphone anymore? Strange.
wait, was
Share
that
again, please.
muted?
Mm-hmm. Share again, please.
Yeah, I'm sharing. Hold on.
It lags. Oh my god. I can't imagine how fragile the internet cable of Vietnam is. The whole country depends on only one cable. Oh dear. One undersea cable. It's terrible. We need other alternatives for the country to develop. Otherwise, nah.
Yeah, so yeah, and that's it for Yeah.
Okay, so now write about varying initial values and rate of change and the effect they have on the graph and equation of lines. We should include a note that distinguishes between direct and partial relationships. Oh, notebook, huh?
Yeah. It's just yeah. Yeah, I've been
So
writing
what do you
down.
write? So what do you write then? So what do you often write then?
Yeah, I've been writing down my notebook.
Okay.
And that is like it to the whole examining direct and partial variation.
Mm-hmm. All right, so I think that's it, isn't it?
Yeah, that's it.
Okay, that's it for today, and probably we'll see each other tomorrow. So what for tomorrow then?
Maybe a bit of science.
Say again? What kind of science? Like chemistry, isn't it?
Yeah.
Okay, then chemistry tomorrow. I'll see you tomorrow then. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn sẽ được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.